All right, here's part 4 of this section 3 on the redesigned SAT, their first practice test. In this part of the video, I'm going to work on questions 16 through 20, which are the last 4 in this part. Those are the 4 where it's not multiple choice. So I've done the first 15 in different videos. So we'll pick this up here at number 16, where you have to actually figure out the answer and write it in. So for 16, you're told that t is greater than 0, and that t squared minus 4 equals 0, and asked what is the value of t. You got two options here. One way is to factor. T squared minus 4 is a difference of squares. T squared is a perfect square. 4 is a perfect square. So it's going to factor to t plus 2 times t minus 2. That's equal to 0. So that tells me that either t plus 2 equals 0 or t minus 2 equals 0. So either t equals negative 2 or t equals positive 2. However, in the problem, they told you the t is greater than 0, so we must be talking about this solution right here. I don't know that you want a separate way to do this, but another option is we could solve for t more directly. We don't need to factor because there's only one t in this equation here. So I could have added 4 to both sides of the equation and then taken the square root of both sides of the equation. Just the thing to be careful of there is anytime you decide to take a square root of both sides of the equation. Not anytime there is a square root, but anytime you decide it's a good idea to put one into the problem, you got to put in a plus or minus. So I really have to put in this plus or minus here. I get that t is equal to plus or minus 2, but then I say, wait a minute, t was supposed to be positive, so it's only the positive solution that works, and my answer is t equals 2. So had I forgotten to put in the plus or minus, I would have gotten lucky in this case. But generally speaking, it's a good idea to remember that there are two different solutions to this equation. If t equals positive 2 squared is 4. If t equals negative 2 squared means negative 2 times negative 2. Negative times negative is a positive. All right, that's enough on that. 17. A summer camp counselor wants to find a length x in feet, which is labeled in your picture right here, across a lake, and it tells you that AB, EB, BD, and CD were determined to be 1,800, 1,400, 700, and 800 feet respectively. What is the value of x? What I would do is label my picture. It tells me that AB is 1,800. So I have an 1,800 right here. You might want to just call that 18 because all of these are multiples of 100, but then just remember that your value of x needs to be multiplied by 100. I'd be afraid that I'd forget to multiply by 100 at the end, so I'm going to leave this as 1,800. The next one, EB, is equal to 1,400. So EB in my diagram is right here. And then it tells me that BD is equal to 700. So that's this length right here. And then finally it tells me that CD is equal to 800. Probably worth spending an extra second to make sure you label these correctly. AB should be labeled as should EB, BD, and DC, and those should be 1,800, 1,400, 700, and 800 respectively. Cool. Segments AC, in other words this line, and DE, this line here, intersect at B. Yep, sure looks that way. And angle AEB and A and CDB, so this angle and CDB, the angle at E, it's labeled for you. This angle right here, AEB, is the same as CDB, this angle right here. Okay, that was nice of them to tell us. Okay, so what it wants to know is what is the value of x? What is this thing right here? What you have to recognize is that we have similar triangles here. The way I know we have similar triangles is that when we have two lines intersecting like this, that tells us that these two angles are the exact same. That this angle is the same as this angle. And if this angle and this angle are the same, and this angle and this angle are the same, that tells us that their third angles are also the same, because the sum of the interior angles in any triangle have to be 180 degrees. And if I used up the same amount over here in these two as I used up in these two, I have the same amount left over for this guy. So I have, maybe I write this somewhere, similar triangles. And that's really useful to have similar triangles. That tells you that the lengths of the sides are proportional. So the way I can think about this is x is what I'm trying to figure out. X is the side length that goes between the angle that I marked with 1 and the angle I marked with 3. So that one and the one that's between 1 and 3 over here, the 800, are going to go together in some sense. And then over here between 1 and 2, and over here between 1 and 2, I have values. They're 1400 and 700 respectively. So those guys are going to go together. What I'm saying is that this x divided by this 1400, so this one divided by this one, has got to be the same as this 800 divided by this 700. Make sure you line these up right. It would be a shame to come through all these conclusions and have one of your fractions flipped upside down. The way I got with this is, again, remember the x and the 800 go together. Those are right across from each other. And the 1400 and the 700 go together. And the x and the 1400 are in one triangle, and the 800 and the 700 are another triangle I get here. If you get to here, it's pretty straightforward. You want to solve for x, get the x all by itself, multiply both sides by 1400. So x is equal to 800 times divided by 700 times 1400. How am I ever going to do that in my head? I don't have a calculator. Well, don't worry about it. 1400 is exactly twice 700. This and this cancel out and turn into a 2. Maybe I'll write like a 2 up there. So really, x is just double 800. In other words, x is equal to 1600. You can give that a reasonableness check. Wait, does that seem right? 1600 is exactly twice as long as this one? Oh, right, because this one right here is exactly twice as long as this one. Sure, I guess that makes sense. 18. System of equations. What's the value of x? You can do this a few different methods. You can do this with substitution or with equation addition, which is the method that I prefer. So I'm going to do equation addition. Note that it wants to know the value of x. So I want x, I'm going to get rid of the y's. The way I'm going to get rid of the y's is I'm going to take this first equation and I'm going to multiply it by -2. The reason I chose -2 is because I'm kind of looking into the future and I know that I'm going to add these equations together in the next step and I want my y's to go away. Why you want your y's to go away? Because I want to be left with x's, what it's asking for. So I multiplied this first equation by -2. I left my second equation alone. Now I'm going to add these things. -2x plus +1x is -1x. I have no y's. 18 plus -25 is -7. So my value of x is equal to 7 here. You can also do this with substitution. You can say, well, y equals -9 minus x. So plug that in down here and algebraically solve for it. And that'll work. But I think that ends up being more algebra. If you can learn this equation addition trick, it can save you a lot of time on tests like this. So I'll present this way. 19. In a right triangle, one angle measures x degrees, where the sine of x is 4/5. What is the cosine of 90 minus x? Okay, I like to draw a picture. I'm very visual. It's a right triangle. There's a right triangle. It's a right triangle. There's a right angle. There's my right angle. One of the angles is x right here. Wait a minute, if one of the angles is x, all three of the angles have to be 180. I'm using up 90 of them here, so that means that I have 90 left over here. If this angle is x, this angle right here is 90 minus x. And that'll be really useful. If this is x, this is 90 minus x. If the sine of x equals 4/5, maybe you have memorized this SOHCAHTOA thing, that the sine of an angle gives you the ratio of the lengths opposite to the hypotenuse. So I can draw this triangle here where the angle or the side length opposite x is this 4 and the hypotenuse is 5. So this is my triangle right here. What I want is the cosine of this angle. Well, again, using SOHCAHTOA, which hopefully you know what that means. If not, Google it, learn it in a different video. The cosine of this angle is the adjacent side divided by the hypotenuse. So the cosine of 90 minus x is going to be 4/5 as well. My answer is going to be 4/5. It's going to be the exact same thing here. That's not special to this problem. Anytime the sine of an angle is always equal to the cosine of 90 minus that angle because of this picture. But I thought it would help to have the picture to figure this out. Information that you don't need. If you have a right triangle and the hypotenuse is 5 and one of the side lengths is 4, then the other side length must be 3. This is 3. I didn't end up using this in this problem, but if it asked me for the sine of 90 minus x, for example, I might have needed to know that this was 3 here. And there's this thing called a 3, 4, 5 right triangle, which pops up a lot on tests like this. If you didn't know this was 3, you'd know that this squared plus this squared has to equal this squared, using the Pythagorean theorem, so you could have figured this out. But for this problem, you didn't even know that 3, so why even bother writing it? Last problem, number 20. A equals 5 root 2, and 2a equals the square root of 2x. And what it wants to know is what is the value of x. Okay, so a few different ways you can do this. What I would do is kind of substitute in. I'd say, wait a minute, if a equals 5 root 2, then 2a must be equal to 2 times 5 root 2. In other words, 10 root 2. And you're like, wait, shouldn't that be like, I don't know, 10 root 4 or something? Doesn't the 2 have to hit both of these guys? No. You only have to distribute the 2 if you have multiple terms. Terms are the same thing separated by pluses and minuses. This is all one term here, so only one thing gets hit with the scalar, the 2 that I'm multiplying both sides by. I get 10 root 2. Anyways, if 2a equals 10 root 2, then what I really have is 10 root 2 equals the square root of 2x. All right, this is the equation that I have. So what I can do is I could square both sides of the equation to get rid of this square root. I get 10 root 2 squared, which I'm going to write as 10 root 2 times 10 root 2, because I think a lot of people would mess up the rules that you do with the exponents. This is 10 times the square root of 2, times 10 times the square root of 2. Multiplication is commutative, meaning I can multiply in any order I want. I can do the 10 times the 10 and get 100, and then the root 2 times the root 2 to get 2. I could get that 200 is equal to 2x, and therefore x is equal to 100. Note that when you were squaring 10 root 2, really all you do is you take the exponent and you kind of distribute it down to each of these factors. You get the 10 squared times the root 2 squared. But you have to know that that's how you treat when you have this exponent like this, that's how you treat things. So in case you didn't know that, I wrote it out like this. But either way, you get 100 times 2, which is this 200 here. Anyways, the answer to this one, x equals 100, is the solution to this problem. So I guess I'll call that good and end this video.